Yep, that's it.
All right. Hello, everybody. Today we are going to talk about one of the most interesting and sexy topics within OpenBMC, our infrastructure. My name is Andrew Geisler. I do a lot of work in the state manager area, and then I also maintain and work on a lot of our infrastructure and CI features. So to understand the infrastructure and what we do here, you first have to kind of understand our software layout. I think most people are probably pretty comfortable with this, but I figured it'd be good to give a kind of a quick summary of how it works here. So we have an organization out in GitHub called OpenBMC. And then underneath that organization, we have, I think it's 100 plus repositories, but they're kind of broken up into three areas. So the first is our application repositories. So this is where the actual function is. It's a lot of C++ code. It has make files that are Meson or CMake or AutoMake based. Your web server, your state management, your error logging, all of that type of stuff. So that's what we fit under what we call our application repositories. Our meta repositories, so this is OpenBMC / meta dash something. So within OpenBMC, we use Bitbake. Bitbake is our build environment for how we package our OpenBMC distributions together into Flash images. And a part of Bitbake is this concept of meta layers. So these meta layers provide a certain level of function. Within our area, it can be broken down based on the BMC hardware. So we've got like a meta A speed layer, and we've got a meta Nuvoton layer. It could also be broken down based on company. So there's a meta IBM layer. It could be processor type, meta open power, meta Intel. So there's lots of different meta layers out there. Within OpenBMC under our organization, we actually implement these as subtrees, these meta layers. There's a variety of reasons for why we did that, and we'll discuss that a little bit later. But right now, those meta layers contain the Bitbake recipes that talk about how to build those application repositories. So there's lots of neat things within Bitbake where, if you've got one of those supported make combo libraries, it's Meson or CMake or AutoMake. There's lots of recipe magic that'll just build those for you. It's where you put your dependencies, the other repositories that you need, and tells basically the Bitbake build system how to package your application into an image. Then there's the integration repositories. So that's OpenBMC / OpenBMC. And so this is what contains all of those meta repositories. And it's when you want to build a system, it's what you clone to build the different types of systems that OpenBMC supports. It pulls in the OpenBMC meta repositories. It also pulls in upstream repos from Yocto. So things like meta open embedded, the Pokey reference system layer, meta security. We also pull in like meta Raspberry Pi. So we pull in a variety of those layers into OpenBMC from outside of OpenBMC. We utilize those a lot actually for a lot of our base stuff, like GCC and systemd and all that type of stuff. So that's where you generate the Flash image. And then basically we've got a subset of tools that kind of move this code from the next place to the next place. So there's an OpenBMC config tool that basically sweeps those meta repositories up into OpenBMC, runs it through the CI process, and then it gets merged. And so I run that tool on a fairly regular basis. Feel free to throw out any questions you have along the way. That is a high level of our software layout. All right, so automated testing. So what happens with all these different repositories? So within the application repositories, remember this is kind of the C++ code, your web interface, your web server, your state management, all that type of stuff. So what happens when you commit that code up into a Gerrit repo is we run what we call kind of individual repository CI. So within a Docker container, we will build that repository and all of its dependent libraries into that Docker container, and then we will run we'll run the Google test suite. So if you have defined Google tests, unit tests for your repository, those will get run as a part of this process, and then that will get reported back to the Gerrit repo where the code is up and for review. So that process supports Meson, CMake, and AutoMake repos, which is pretty much what I think all of the OpenBMC repos are using now. You know, we all started out, I think, on AutoMake. We did some CMake, and there seems to be a general movement within the community to move to Meson. It's a bit simpler. It gives us a lot of stuff for free when it comes to unit tests, when it comes to like coverage and some of the other things. So that's kind of what I've been seeing. So then the meta layer, right? So that first layer that first test does not build any Flash images. It's not really doing anything with BitBake. It's really just building that individual application repository and its dependencies and running the unit tests. It's not even running the applications associated with it. So once that code gets merged into that application layer, it goes into the auto bump process. So auto bump is another tool that we have. It's a cron job that runs every 5 minutes, and it looks for any new code that's been put into the application repositories, any code that's been merged. And if it sees some code, it'll generate a Gerrit commit into the appropriate meta layer that will then pick up that code. So this is where you're taking that change that you put into BMC Web or Phosphor State Manager, and you're bringing it into the appropriate meta layer, which in most cases for us is MetaPhosphor. That's where the majority of OpenBMC code is going into. So the autobump script will basically just update the BitBake recipe to say, use this new Git version from the application repository, and it'll submit that into Gerrit, which will then trigger our meta repository CI. So this is where we'll actually do a BitBake for a variety of OpenBMC systems. So we have, I think, 6 or 7. We'll take a look a little bit later on here. Of systems that all need to successfully build when a new change comes in. So that change comes in, we do a BitBake, we build it for all those systems, and then we also have some CI that occurs there. We'll boot one of the images up in QEMU, and we'll run a set of tests that say, hey, did it get to the BMC ready? Is the web server working? Does the REST API work? So it'll do kind of a basic sniff test of that. The integration repository, so once that meta repository code gets merged, it will then be swept up into the integration. So this is the OpenBMC/OpenBMC. So this is kind of how you officially get in there. So once it passes the meta CI, it goes into the integration CI, which is really duplicating a lot of what we did in the meta layer. It's building the Flash images for the same systems. It's doing that basic QEMU CI. And then both these layers have a little bit of hardware CI, which Ralph's going to talk about a little bit more later. But that's kind of the flow we have right now. There is an interesting document, if anybody's interested, that's talking about something maybe in between the application repository CI and the meta repository CI. So it's where we would actually start those applications within that Docker container level, and we would mock out some of the dependent dbus interfaces. So we'd still just be testing that, that one application repository in isolation and kind of mocking out its dbus dependencies, but we could actually start the application and test some stuff. So that looks pretty interesting. It's out in the document repo. There's a lot of good discussion going on with it. So that might be something that kind of gets added on probably to the application repository CI step.
So Andrew,
yeah.
I have a quick question. So in the previous slides, if you saw that the second part, build and run, and does it report if there is a G test to be run and if there is any failure? How does it report to the review page? Because I remember for the build, it says build failed. And for the G test also, it says failed and verification is -1.
Yeah. If the application repository fails, it'll come back and basically give you a -1 score on your Gerrit review. And then you've just got to follow the link. So if you follow the link, it'll take you to the Jenkins job, and then you can click the console output. And then you it's not the most user-friendly, but you got to go through all the output, and you'll find kind of the G test or whatever failed. A lot of times it's format code, because we do also, as a part of, format your code and make sure it follows the Clang formats. So yeah, that's what you get now.
So that is for build and run both. It shows into the console.
Yeah, you'll see both.
Okay. Yeah,
building
that's
of
the,
the,
yeah.
usually the Docker container part, I mean, building the Docker container part is usually pretty quick because it's cached. And then, yeah, then you'll see the compile of your code. And if that passes, then you'll see the unit test, and it's all in that Jenkins console.
Okay, thank you.
Hey, quick note on the application repository repo. The web UI repos use npm node package manager. So we do use a fourth.
It's true. Don't want to leave out the web stuff. I'll add that in there. All right, so high level infrastructure overview here. So we've got two web interfaces, right? So we got jenkins.openbmc.org, and that's running our Jenkins instance. And then we've got our Gerrit instance, which is, for legacy reasons, it's at this gerrit.openbmc-project.xyz. If you type in gerrit.openbmc.org, that will also redirect to the same place. So we've basically got those two software entities running for our infrastructure and CI. We've got 6 compute nodes that we use, 2 provided by Google, 2 provided by IT Renew, and then 2 provided by IBM. 5 of those nodes are just general purpose build. So they will do both the bitbake builds, and then they will also be run for the application CI. One of the nodes only is utilized for CI. It doesn't do the bitbake. Bitbake's really resource intensive, as I'm sure everybody knows. And so I chose not to run that on the systems that are running our Jenkins and Gerrit instances. So there's one system that runs those 2. We've got a lot of scripts and tools out there that CI and our infrastructure use, but they're also very useful, I think, for just general development. And so I'm gonna do a demo of that later that kind of shows how those pieces work. The 2 main scripts out there that are in our OpenBMC build scripts repository are the build setup.sh. And so that's run as a part of our CIs for building the meta layers and the integration layer. So it does a lot of neat things. It's got proxy capabilities into it if you're behind firewalls. It's got state and download caching built into it. So it'll share, the state across the different builds happening on that system. It supports a variety of OpenBMC targets. It will clone repos, for you by default, or there's a lot of ways to fine tune it and have it do pieces. So that will generate the Docker container needed to build an OpenBMC image, and then it will build the image within it. So CI uses that to obviously test the different Gerrit bumps that are coming in for the meta layers and the integration layers. And then the run unit test Docker is another script that is used by our CI infrastructure and also used a lot, I think, by the development team. So this is a way to basically, similar idea, it will generate a Docker container, and then it will run whatever application repository you've pointed to it within CI. So it'll do the Clang formatting, it will build the code, it will run the G tests if there's any present, it'll do source code analysis, it runs a bunch of different things. And it's just a good way to test your code locally before pushing it up into Gerrit.
Do we need more compute nodes? Do we ever have really long queues?
Well, that's a good lead into this next page of some of the things that we need to do. So the first one on the list is to get rid of our meta subtrees. It does, when we introduced that, it really did. It doubled the amount of compute power we needed, right? And it's very redundant to a certain extent, right? So somebody makes a change into the metaphosphor layer. We build that change. We build a bitbake image. We test it. And then it goes up into the OpenBMC layer. And once again, we build that same change. The reason we do it twice is that some other change could come in to that integration layer that affects that change from metaphosphor, right? So all alone, that metaphosphor change built okay, but when you combine it with, something from Meta IBM or Meta Open Power, right, it breaks. And we got to catch that. We don't want to put that into the OpenBMC integration layer. So what we used to do is everything just went directly from the application layer into the integration one, which was, OpenBMC/OpenBMC. And we broke it out into those subtrees, mostly, from my understanding, for a maintainer permission capabilities, right? We couldn't give, all those meta layers have lots of different maintainers. And we didn't really want to give everybody maintainer, capability to the integration layer, that OpenBMC/OpenBMC. So the meta subtree concept was a way to give maintainership to these different layers to people. And so we've done some research, and there is a way within Gerrit. It looks like there's a plugin within Gerrit that you can configure to have a common repo, but then only give maintainership to certain subdirectories under that. And so we've had it on our list for a long time to look into, because this would really help in this area. But of course, there's just not enough time in the day sometimes. But it also leads into the next discussion, which is potentially just getting rid of Gerrit and moving to a GitHub pull request model. This has also been churning around a lot. I know the TSC has been talking about it quite a bit. I'm mixed, because I think, like a lot of people, I do like the Gerrit code review web interface better than the GitHub pull request piece. A part of that can be familiarity, and I have had the chance to talk to some GitHub product engineers, and there's a lot of effort on their part to improve the code review process. They've got a new command line tool out that allows you to not have to ever go into the web UI, so you can generate pull requests automatically. And that's kind of a clunky piece too, is a lot of times you have to go into the web UI to generate your pull request, versus Gerrit, where it's just push here and do this. From a person who maintains the infrastructure perspective, I kind of would like to get rid of Gerrit. It's not a huge piece of work, but every time I need to upgrade Gerrit or do something to it, it's very stressful. They change the database version, or the Docker container I'm running into updates something and it's no longer compatible with the Gerrit database. And my disaster recovery has been tested once. I do rsync off the Gerrit stuff every hour, but I'm just worried that someday something might catastrophically happen, and I'm going to have a lot of really mad people at me about losing all their Gerrit code review comments. But overall, it is just, Gerrit is just running within a Docker container on one of those compute nodes, and it really has been pretty simple. But I do feel like it kind of raises the barrier for new entry into OpenBMC. We can get a long conversation about the CLA and the barrier that introduces, but after you get past that, this whole Gerrit thing is also kind of new from a development flow to a lot of people. So we'll stay tuned. If we do decide we really want to stick with Gerrit, then I think we do need to look at that first part and look at that plugin and try to find a way to get rid of the meta subtrees, because it does just really does increase the amount of compute resources we need. Going back to your question, Gunnar, there's definitely times when we have a backlog in our Jenkins queue for work. I try to, because I can control a lot of the way things work, like I won't push the auto bumps into the integration layer until the end of the working day, since it seems to be, it tends to be a quieter time. So I kind of help a little bit with the distribution of the work based on that. But there's definitely times, especially when new Yocto distributions come in and that starts really churning up our build queues, that we run into problems here. And it also prevents, us being able to do new things like this third bullet here. So this comes up a lot, can we do that bit bake processing at the application layer? So I've pushed a change into BMC Web. It's gone through the basic CI and run the Google tests on it. But, I really, with BMC Web, you want to run that web server and you want to see, hey, did I break anything from a REST API perspective and all that type of stuff. And so what happens right now is we merge that code in the repository layer, and it goes into the meta layer, and then that's when we find the bugs, and the code's already been merged down at the application layer. So then you got to go backwards and you got to revert the change, or you got to fix it. And so it'd be nice if right at the application layer, we would maybe do a dev tool modify and just put that change into a build it, and then run it through our normal CI process. But that takes a lot of resources, right? To do a bit bake on a per commit level at an application layer would take a lot of work. So I think, if we got some more compute resources, we got rid of the meta layers, we could potentially do a few targeted ones, ones that we see the most issues or that have the most activity or are the most critical. So I'd really like to see that. Another thing we've been pushing on too is getting more hardware CI. So right now, when we talk about hardware CI, there's really just one system. It's an IBM Witherspoon system, and so I run a separate Jenkins that's downstream. And so what it does is it monitors for those upstream CIs to finish for the meta and the integration layers. And once that completes our, it builds and we've run it through the QEMU CI, my downstream Jenkins will then grab that flash image that was generated for the Witherspoon system, and it'll put it on real Witherspoon hardware, and it'll run it through a set of tests. It'll make sure that it boots. It'll run the Redfish validator, which has definitely, been good since we introduced it. It definitely finds a few things here and there. And so, yeah, and that's good. So, we as IBM know that we've got a stable Witherspoon platform that's working with the master code. The community definitely has gotten a lot of benefit from just keeping things stable in the master release. And I've definitely been trying to work on encouraging other people to do the same thing, because there's no special configuration or anything you need. You just set up a downstream Jenkins, you monitor for the meta layers that your system is interested in. And then you flash it, you run your tests, and then you just make a comment to the Gerrit review that says, hey, this passed or failed. Is how it works right now. So I'd really like to see us get more machines. We've talked for a long time as a community about some sort of reference system. I think there's a desire for that, and we don't have one yet. Maybe one of these days, but that would be a great thing to also obviously be running through this type of CI process.
Hey, Andrew, one question.
Mm-hmm.
This is Subtrees here. So you mentioned hardware CI is only running on IBM's Witherspoon platforms right now, right? So if AMD wishes to donate a system for hardware CI, where should we kind of send it? Or should we host it in our campus with public access? How does that work?
Yeah, you would host it, and it doesn't need to be publicly accessible, right? So what I do is I have a downstream, Jenkins job that just monitors upstream, and when it sees, a change pass, it pulls that change down, and then it'll load it onto that hardware, and it'll run the test, and then it'll just make a comment to Gerrit and say, hey, this passed or failed. So that's the flow. I've got a link in here about how to set that up. So yeah, I'd be more than happy to help you get that set up.
Oh, sure, I appreciate it.
Because yeah, I think the more the better, right? The better stabilization we get of our code, which is good for everybody.
Yeah. Thanks.
Yep. So other things that definitely come up a lot are tracking flash size, DRAM usage, and CPU utilization on a per commit basis. This is challenging at best. We do every day when we've got a Jenkins job that'll build just the latest code at master, and it'll run a script that we have that'll analyze the file system. So we do have something that at least shows you, high level what the different applications are taking up in the flash space of a system. But there's been all sorts of ideas like, well, we need to commit that to a Git repo every day, and then we need to put some graphing software on it, and we could kind of see what's growing and what's shrinking over time. Currently, it's mostly, hey, we just pulled this new code down and it doesn't fit anymore in our flash image. What happened? And then you kind of have to go back and look at this stuff. We had this happen, a couple weeks ago. So there's definitely a lot of optimizations here. And also we've had problems, where all of a sudden we've got, out of memory issues, or our CPU's running at 100%. And I do know we've got I noticed recently a new resource monitor of some sort that showed up in the flash images that will give you a little notification when you exceed certain limits on CPU and stuff. So that's kind of neat. I always see it when we do a code update, right? Because code update really hits the CPU. So maybe we could tie that in somehow. But just to be able to go back in your history of changes coming in and know what change, bloated the size or all of a sudden doubled your CPU utilization, it just makes life a lot easier from a debug perspective. And then something kind of a little side project I've been looking at is creating a Grok. So I use OpenGrok in our downstream source a lot, and I find it very, very useful. So I've been looking at getting us one for OpenBMC externally. So stay tuned. All right, this is my amazing artwork of the process flow. It's kind of just to visualize what goes on. So step one, we push the code up to Gerrit. So this is into an application repository. So at that point, we run the unit tests. So this is the unit test run unit test docker.sh. So that will build the Docker container and then run the G test within that Docker container. So Jenkins runs it. It actually updates Gerrit with the code review results, or not with the code review, but with the results of that run. Eventually that it gets reviewed, it passes its CI, and it gets merged into that application repository. So then we've got this auto bump script, which is monitoring those application repositories. And when it sees new code, it will generate a Gerrit commit that pushes the change into the correct meta repository. So like I said, usually for us, that's metaphosphor, but it definitely varies. At that point, we've got a separate Jenkins job that builds that full image, right? So it bit bakes the image for all of the machines that we have in CI. It then runs one of those systems, which is Romulus, which is the best supported QEMU system. So it loads the Romulus CI image from that commit into QEMU, and it verifies that it can pass the basic tests of, does it get to ready state, and do the REST APIs work, do the IPMI interfaces work? So that's what we get out of the basic piece there. Once that completes, this is where we kind of have a separate, we can have multiple of these, right? So I run a separate Jenkins server that's monitoring for that stage 4 here to pass. Once it passes, it grabs the flash image generated by the upstream Jenkins for Witherspoon. It flashes it on our Witherspoon hardware, and then it runs another set of CI tests that come out of the OpenBMC test automation repo. So that's a robot test framework. So we use that for both the QEMU tests and actually the hardware CI tests. And that has a whole set of different types of tests, but there's basically a CI test bucket that, once again, make sure you can get the ready state, make sure there's no applications fail, make sure the system can boot the host up and power it down, redfish, IPMI, test all those interfaces. So there's a set of about 20 tests that it'll run on the hardware. It takes about 20 minutes to flash it and test it. And then that Jenkins job will make a comment up to the Gerrit repo on whether or not it passed or failed. So it doesn't get a score, because we don't really want people's hardware to prevent changes, right? You can obviously get involved and say, hey, this is why it failed, you should fix this, but it's just a comment at this point. And then once the meta layer, a little note at the bottom here, we basically do it all over again when it goes into that integration layer, that OpenBMC layer. Any questions on this? It's just kind of the flow we talked about here. Alrighty. So this is just a reference, and I'm actually going to bring up the web interface so that we can kind of walk through some of these jobs and how the different pieces work. So I'm not going to talk too much about this. We'll talk about it when we look at the page. So some of the common questions that I get, how do I get my system on the list for CI? Number one way is to donate a compute node. That's a good way to get your system in the list. But also, just there's no hard or fast rules. You make your case that your system's good for the community. Maybe it covers a meta layer that none of the other systems cover. Maybe it's a system that's widely used. Yeah, it's pretty open. I do like to say that if we add a system, I like to take away a system. So sometimes it's arguing why your system is more important than another one. I think we got pretty good coverage up there. We try to get, all the different layers. That's really the focus, is to test as many of the different meta layers as we can. Another question is, what do I do when I see this user not approved for CI message? So there's a link on contributing, and the main thing is you need to get on a CLA. Once you get on a CLA, whoever puts you on that CLA for your company should also have access to the CI Gerrit group. So there's a Gerrit group for each company, and basically they just put your GitHub ID in there to say you're approved. And at that point, the Jenkins job that determines whether or not somebody's approved or not is just looking at those Gerrit groups every time a Gerrit commit comes up. So after that, you will be approved and CI will run automatically whenever you push code into Gerrit. If you're signing an into ICLA, then there's an ICLA group. So me or Kurt or somebody will get you into that Gerrit group once you've gone through the process.
And is the company manager of the CI groups, Gerrit groups, are they the same admins for the CLA?
Yeah, usually, or they know each other and they coordinate it. But yeah, usually it's the same person. Okay, how often do things get updated? So the auto bumps are automatic. You know, when you merge code into one of the application repositories, basically every 5 minutes, auto bump is running and looking for changes. So it does lead me into saying that it's really appreciated. You know, if you've got a string of commits from somebody, you know, in a chain, and you're reviewing them, that it'd be great if you just +2 all of them and then get at the end and merge them all together. That really helps our CI infrastructure. When you merge them onesie twosie, you know, you get an auto bump for the first 2 commits, and then you get another auto bump for the next 2 commits. You get another auto bump for the next 2 commits. And so it can kind of eat on the infrastructure a bit. So just a general tidbit, if you can. I bring in the repositories outside of OpenBMC every couple weeks. So this is where we pull in these ones listed here. The main really important ones that we depend on a lot are the meta open embedded in the Pokey reference layer. So this is where we get new boost layer, new boost, new systemd, you know, new compilers, new fundamental things to our build. It's also where we find the most issues, as we've been finding recently. I know, you know, Gunner, we had that crazy one with the file system paths and the web UI. There's a crazy one going on right now with the OS release recipe. So yeah, there's definitely always something, and I appreciate, you know, people's help when we do bring in this stuff, because it's all over the place and it's definitely difficult to get to the bottom of some of it. I try to do the easy stuff when I can and just put the commits up, but this is definitely painful, but it's cool. We're cutting edge, right? We are always right on the latest of all the code and the compilers and the tools, and I think that's neat to say with our community. Why don't we use free open source cloud environments for testing? So there's a lot of environments out there that support open source for free. I've looked at them, some of them, and the main things I see is that, you know, BitBake takes a lot of compute resources. I think, you know, a lot of us have seen, you know, you need at least 16 gigs of memory, you know, you need at least 8 CPUs, you need a lot of hard drive space. And so a lot of these environments are more meant for really quick tests. I think we could probably run like our application CI potentially, but, you know, that's a drop in the bucket compared to, you know, what the BitBake things do. And a lot of those free environments don't provide ways to persist your cache data. So we definitely utilize the BitBake state and download caches a lot. It takes, you know, a build that could take an hour down to like 10 minutes when it's just a really minor change. And then also the Docker container caching is a big thing that we do on these systems as well for the builds. But I'm always up for ideas if people have ways that we can utilize some of this stuff. I'm all ears, although I definitely prefer you come in and say, hey, Andrew, this is how we do it, versus, hey, Andrew, did you look at this? Because, you know, that always takes time. All right, so how do I get my new OpenBMC repo added to CI? So you can just shoot me an email or find me on IRC and just, you know, CC the mailing list in case I've got a backup going on. But yeah, it's pretty easy. I just update a couple Jenkins things and we'll start running your new repo in application CI. And then I just added this one. Docker is putting out some pull rate limits, and I know Patrick brought this up a while ago, and it's about to roll out, and I am actually a little concerned. You know, it looks like we're only going to get 100 pulls per 6 hours. And when you look at something like the application CI, we do spread it across all of our nodes, so we might luck out. But the way this project's been growing, I think we might have to look into something here. So stay tuned for that one. All right, any other common questions people would like to add on here? All right, well, I was just gonna show you guys 2 things. I was gonna take a tour of our Jenkins and show you how do we use that unit test Docker locally. So first, let's take a look at Jenkins. So we're out at jenkins.openbmc.org. I've just got this done alphabetically. So you can, I kind of tried to put a key up here. So if it's CI dash something, it means it's one of our CI jobs. If it's latest dash something, this is where we're taking code that's been merged into the master branch, and we are building that. So we do a variety of things with that code. And then release, not really a big thing for us. Nobody seems to really use OpenBMC releases yet, but I do try when we tag to do a release build, so it's there and available if somebody needs it. So that's high level how they break down. The CI meta job is where we're building all those meta layers. You can see, oh, we got a meta open power, we got a meta phosphor, which is definitely a lot of meta phosphor. You see a lot of red here because of this current OS release issue. So I pulled in a new pokey last week, and there's some sort of crazy problem that I still don't understand, and that we've been talking to the upstream about. And I'm really hoping Brad figures out. But we're having a lot of intermittent CI problems right now due to that issue. And it's just definitely one of the consequences of always being on the latest. CI OpenBMC, so that's the integration layer. So this is the code that's building the OpenBMC/OpenBMC. You can kind of see, you can see the list of systems that we build. So we build 1, 2, 3, 4, 5, 6, 7 different systems whenever we build the meta layer or the integration layer. And so these 7 systems give us a pretty good coverage of all of our different meta layers that we have. This CI miscellaneous is just kind of some of the miscellaneous jobs. So this build seed is whenever I add a new node, or sometimes I just need to reset one of our build nodes, I'll run this job and it just basically builds all the machines. It's to build up the state cache before we put it into the main job. The build script, so we've got tools, like the build setup and the run unit test Docker. So those will come through this job just to make sure that they still build. We've got a specific, certain repositories want to make sure they build on PPC64LE. So this is just a job to make sure it runs there. And then this user ID validation, that's the one that looks at those Gerrit lists to check if the person's in one of those approved Gerrit lists. So that's the user approved for CI or user not approved for CI job that runs there. CI repository, so this is where the application CI works. So, this is kind of what we were talking about earlier, where if you want to look at a fail, you can just come in here, and there'll be a link to this in the Gerrit. So you can kind of scroll through and see the building of the Docker container and look at what failed. So in this case, it looks like a compile error. So yeah, this is where all the application CI happens. And if you look at the trend, these all kind of depends on the repo and how much the building takes, but it can definitely be very quick. I know BMC web ones take a while, but there's a ton of things that happen now within the BMC web page. But yeah, it's all pretty quick here. Latest master, so this is where we will just build periodically the latest code merge. You can click on here and see what the change was versus the last change. And this is also where you can come in and you can look at these build artifacts. So you can go get any of the images you want. And there's also this results.txt out here. And so this is where we show you what's taking up the space in the file system. And so this obviously gets more interesting when you're comparing and contrasting to previous builds and when you run into issues. But yeah, it's just a good place to be like, hey, what's taking up all the space here?
And this builds a few times a day, or does it build every time something new is pushed to?
I think it's periodic. I think it looks every hour. So if something new has been merged, it'll grab it. But I tend to only do it once a day. I tend to only merge into the integration branch once a day. So you'll only usually see it once a day. Okay, let's see. So I also build the latest master SDK. So if you ever need an SDK for any of these systems, you can come in here and out in the build artifacts, grab it there. QEMU, so we host the QEMU, we host a fork of the QEMU repo under OpenBMC. And so basically these jobs are just set up anytime new code comes in to build them. And then our CI infrastructure uses these, right? So it comes and just says, hey, give me the latest, QEMU tool for this that's passed, latest successful. So that's what these jobs are used for. But it can also be used, I use these to just, grab the latest QEMU tool when I need it. We've got this unit test one. This one definitely takes forever because it runs every application repository and it basically runs it through the CI stuff and it looks for, and it basically runs the code coverage. So you can click on the output here and get a summary of all the different repositories. And you can see which ones have unit tests, which ones have unit test and coverage, which ones have nothing. And I know that we've been, within IBM reviewing this down, in our kind of downstream discussions and just saying, what repositories are really important to us and where do we need to focus on getting better unit test coverage. So if you go out to the build artifacts here, you can look at all the different repos and you can go out and, for example, you can go into PLDM and you can go into, what is it? Build. And then Mason logs, I believe. Yeah. And then coverage report. So it's not super user friendly. You kind of got to know where this stuff is. But once you can go out and you can get the code coverage for your area here. So you can click on the different pieces and show kind of where the coverage is and how much you have as a high level. So definitely pretty neat. Data is always good, and it's something that I know we've been looking at. Okay, and then the last piece is really this release tag one, which yeah, I've only done 2.8. We migrated Jenkins a while ago. I don't know if everybody remembers that, but we were initially hosted on this rack space system that was just running into a lot of problems. And it was under the Open Power domain name. So it seemed like a good time to just move it over to one of our official OpenBMC systems. And that's when we rebranded the name to jenkins.openbmc.org. So I think we'll have a new tag here coming pretty soon. I do know I saw Upstream has released Garth Gates, I think is the name of the next Yocto release. So we need to start working on all of our layers, adding that support in to say that we support that layer. All right, any Jenkins questions?
For CI OpenBMC, do you build all the machines on a meta layer change or only the machines that use that layer?
Yeah, that's another great optimization that we could do. We build everything. There's no smarts built into it. I know Brad brought that up at one point that, yeah, there's a lot of, we could write something pretty intelligent that kind of figures out like, oh, okay, this is this layer. Does this machine use that layer? No, well then don't even build it. So yeah, definitely a good optimization. But right now it builds everything. Let's see what else I have up here. So I had some links to the build scripts. So this is where you're going to find things like build setup, the run unit test Docker. We've got the scripts here that we use to launch QEMU and run the rest stuff against it. Within the scripts directory. Yeah, this is also where you'll find the stuff that generates the unit test coverage. So you can go out and take a look at that if you want. And yeah, just some of the pieces that work with our infrastructure. And I think it's been a really cool story. Back in the day, Matt Barth did the initial unit test framework for this. And then, since then, there's been a lot of different companies and people that have built on it, adding support for the new build frameworks, adding more things to them, Valgrind and Clang and source code analysis and the format coding. Like there's just been a lot of great things that have come in as a community effort in the unit test area. So I think that's really awesome. This is what I look at. So this is the auto bump. So at the end of every day, I go through this list and say, okay, what's the latest? What's passed? And then I'll merge it in, and then I run that other script that bumps it up into the integration OpenBMC layer. All right. So the last piece I wanted to show. So I am just on a Linux system here. Just sitting out in this directory. So I tend to put everything under this code directory. And so what you can do, so I'm in the Phosphor State Manager repo. So there's really only two inputs needed to the unit test framework. You need to tell it what you want to run your unit tests against. So in this case, I want to do State Manager. And then you need to say, well, what's the base workspace for this code? And so once you have that, I actually just have the OpenBMC build scripts here, and then you can just run this. There are a bunch of other options. So I also tend to usually tell it when I'm doing local development, the test only option, where you can set that, and then the unit test framework will only run, the unit test. So it won't do all the other stuff, the code coverage and the analysis, because that just adds time. I like to run that at the end after I've kind of finished developing. But in this case, we can just run this. And so on your system, looking at this output, this is it generating the Docker container. And so once you've got it cached, it's, as you just saw, it's super fast. This is loading a lot of the dependent pieces, but it's also doing some optimizations where, every repository needs phosphor dbus interfaces. It needs phosphor logging. It needs a lot of those basic repos. And so we'll actually cache that in the Docker container so that we only have to do it every time it changes. So that's what a lot of this stuff here is optimizations in that world. And then, yeah, you can see it comes in and it builds the code. It installs it. So it does a make install of your code in that Docker container. And it runs the Google tests. Everything passed. It gives you the time. And then it does a bunch of other stuff. So it runs Clang analyzers, Clang tidy. It rebuilds it a bunch of times. It does code coverage analysis. At the very end, I think it goes and it looks at looks for code errors. So I've got a few here that I need to look at. So it does all sorts of stuff, and then it'll kind of give you a, hey, you passed, and clean some stuff up at the end here. But you basically do have to have a Docker system, right? Because it does use Docker under the covers. But other than that, the neat thing about Docker is, it installs everything else it needs in the container. So that's mostly all you need to run your unit test locally. Yeah, I think that's really it for me from a closing thought perspective. The infrastructure and the tools and the CI stuff is definitely not my full-time job. It's a part-time hobby in a lot of ways. So I definitely enjoy getting help from everybody and people being interested in, patches and commits. And when I'm putting something out in IRC and I've opened a bug, trying to bring the upstream pokey stuff in, I always appreciate the help and everybody as a community getting behind trying to figure some of this stuff out, because it's definitely not a one-person job. Along those lines, when I do see issues with different machines that are outside my scope, it's nice if I can find you on IRC. So please try to be in that OpenBMC IRC chat. It's a good place to knock a lot of that stuff out quickly. Yeah, that's it. Any questions?
Hey, Andrew, the quick question is, how do I forcefully start the CI in Jenkins for a patch? Like, I know when I submit a patch, the build starts, but if something goes wrong and I need to restart the build again, how do I do that?
So
if I'm not a maintainer.
I think if you log into Jenkins, I think I fixed this. This was a request from somebody at one point where you should be able to click on it if you're logged in, and you should be able to hit retrigger.
Oh, okay.
If you can't, let me know. I think that's the best way. Yeah, because from the Gerrit side, you've got to be a maintainer, I think, to do the OK to test.
Yeah,
right.
Yeah.
So that's one option. But yeah, so this was kind of the way we tried to fix that, is that you can at least come into Jenkins and hit retrigger now on your job.
Okay. Thank you.
Yep. All right. Well, I think we call it. Feel free to reach out or find me on IRC to talk.
Thanks,
Thanks a lot.
Andrew. Thanks for managing
Thanks a
all
lot,
this.
Andrew.